Section 1.1 is the rectangular coordinate system. So what we mean by that is we call the xy plane. The xy plane is also known as the Cartesian plane. It's simply the traditional xy axis you're used to looking at. All locations in the xy plane are denoted by ordered pairs, and in math we are kind of really on the nose when we name things, so it's a pair because it consists of two pieces of information, and it's ordered because we always say we put the x coordinate before the y coordinate. We're also in this section going to make sure we need to know the Pythagorean theorem. For your convenience, I've drawn a right triangle here for you. And so the Pythagorean theorem says that if you take the sum of the squares of the lengths of the two legs of the triangle, it equals the square of the hypotenuse. So I've labeled this. Legs are any side of the triangle that is not the hypotenuse. They are the two sides that actually form the right angle. We're going to use this a lot this semester. The distance formula has been provided for you, as well as the midpoint formula. Now, something I want to note about the midpoint formula. Notice in the formula there is a positive sign here, right? A plus sign in each of these. What you're really doing when you find the midpoint, right? If you look at this, if you take two things and you add them together and then divide by 2, what you're really doing is averaging the two numbers together. So if either of these coordinates happens to be negative, we put in the negative number, right? So we're still averaging their location together. So let's look at some example problems to kind of see how to apply these formulas. And one of the things we're going to focus on in here, these are all exam level questions. They've either come directly off former exams or I've modified them slightly. But we want you to kind of get an idea in this review what exam level difficulty looks about. We're going to look at notation, make sure you're showing your work properly so you can do well on your written test. So the first example says calculate the distance from point -1 to point 2, 3. So if I use my distance formula, that's right here, right? We know that the distance, the first x coordinate is -1. The second x coordinate is 2, so it's -2, so x1 minus x2. That's going to be squared. And then we're going to add that to -1 minus 3. So it doesn't really matter which point you designate as x1, y1, or x2, y2. We just want to make sure we're consistent with our notation. So now I can see that -2 minus 3 is -3. -1 minus 3 is -4. And -3 squared is 9. -4 squared is 16. 9 plus 16 is 25, so the square root of 25 is 5. So these points are 5 units apart. So now we want to find a point R that is the midpoint of those 2 points. So point R, we average the x and y coordinates together. So -1 plus 2 divided by 2, comma -1 plus 3 divided by 2. So -1 plus 2 is 1, and -1 plus 3 is 2. And so I could stop here, but I can simplify it just a little bit better, and we know that the midpoint is 1/2, comma 1. Part C to this problem says, well, let's plot P and Q on the coordinate plane below. So point P was at -1, 1, and Q was at 2, 3. So we go to 2, up 3 places. So those are our points. And it says, on the coordinate plane, sketch a picture with labels that show how the components of the distance formula appear geometrically. So when we calculated the distance, what we were finding was if I draw a straight line from P to Q, we know that the distance of the hypotenuse of the right triangle we would create here, the distance of this line segment is 5. We actually did that in part A of the problem. But now they want us to show how the distance formula actually works geometrically. So all it is the Pythagorean theorem where we've taken the square root of both sides. So if I actually form a right triangle here, we can see that this leg of the triangle, we'll call it the change in the y values, which are y1 minus y2, and then we see down here that these are the change in our x values, x1 minus x2. So now that we have our right triangle, we can see, well, when we take this quantity and square it, this is a leg, and we add it to this quantity squared, which is another leg, it's going to equal the square of the hypotenuse. If you take the square root of both sides, you in fact get the distance formula. Example 2 says find all the points on the x-axis that are a distance 5 units away from point 3, 4. So if you have a point that lies on the x-axis, so if we kind of look back up here, we actually have a coordinate plane here. So we're looking for points that lie somewhere here. Well, their y-coordinates are 0 because you're actually on the x-axis. So what this is actually saying, if they say points on the x-axis, they're saying points of the form x comma 0. So we actually know the y-coordinate of all the points we're looking for. The distance is 5, so this is our d. And then this is going to be our second point, x2, y2. So we can start by setting up the distance formula. And remember, you're not going to have a formula sheet on the exam, so it might be a good idea to just, for practice, write the formula you're using down every time you do a practice problem, and that'll just sort of help ingrain it into your brain in the correct form. So our distance here was 5. Point 1, its x-coordinate is just x. Point 2, its x-coordinate was 3. Then the y-coordinate of our first point is 0, and the y-coordinate of our second point is 4. So now what I have is x minus 3 squared, right, plus negative 4 squared, which is 16, and this equals 5. So now what I want to do is solve for x. So we get rid of the radical by squaring both sides. And I can subtract 16 from both sides and get 9 equals x minus 3 squared. So at this point in the problem, you really have two options. You could FOIL out the right side or expand it, right? Get a quadratic and try to factor, right? Or we can simply take the square root of both sides. But when you do this, you want to be careful because we actually get two answers. So on the right, when I take the square root, I just get x minus 3. But on the left, I get plus or minus 3 because I don't actually know if this expression was positive and then got squared or if it was negative and then got squared. So there's actually going to be two possible answers here. And now we just solve for x, by adding 3 to both sides. And there's x. Now, when you get to this point of the problem or you think that you might be done, you always want to go back and reread the instructions because a really common mistake that students make on exams is they do the underlying math calculations, but they didn't really read the problem and give the answer in the format they were supposed to. So this says find all the points. So we actually expect you to give us a point or a location on the xy plane. So if I take 3 plus 3, that gives me an x value of 6, and the y-coordinate is 0. If I say 3 minus 3, well, that's 0, comma 0. So these are the points on the xy or on the x-axis that are a distance 5 away from our point. So we would actually expect a final answer in this form.